Hello, this is a video on 3-6 compound inequalities. We're going to be looking at two different compound inequalities. There's the kind that are and inequalities, and we'll look at what those mean. And then there's the kind that are or. So we have two different conjunctions here. I know it's a fancy English term, but we'll look at them. So let's look at and compound inequalities. For and compound inequalities, you're going to look at where two inequalities overlap. So you're looking for an overlap of two inequalities. So that means that it's going to be a section of the graph that's in between two dots. So it's the space in between. And it's a defined section of the graph. All right, so we're going to look to shade in between two different dots, not arrows. For or functions, they don't overlap. They do not overlap. They don't overlap. You are going to be shading on either side of the dots. So what you'll be shading in is on either side of two dots. You're basically going to shade in both arrows on that number line. All right, so that's what the graphs kind of look like. That's what you should see when you look at a number line for and or. And now let's go ahead and look at an example of each. All right, so let's do an and one first. Let's say that I know that x is less than 3 and x is greater than -2. So just by looking at this, you can kind of see that there's going to be values that satisfy both of these numbers, right? A number that's less than 3 is, let's say, 1. And 1 is also greater than -2. So there's a section of the graph where these two number lines would overlap. That's what we're going to graph. So let's look at what that looks like. Let's say I've got 0. I'll put 0 here. -1, -2. 1, 2, 3. Put one more. There's that. All right, so x is less than 3. That's an open circle. And I'm going to be shading less than, but I also know that x is greater than -2, so I'm going to put a circle at -2, and it's greater, so it's this way. So everything in between are numbers that would satisfy both of these things. In fact, we can take these two inequalities and sandwich the x in between two endpoints. You see how this matches up here? See how it matches up there? It's sandwiched between the two dots. Conversely, or is where you have one or the other, but there's not going to be numbers that fit both. So we have x is less than -2 or x is greater than or equal to 5. There's not any number that will fit both of these, right? There's not a number that will satisfy both of them. So when we graph, we're just going to graph them separately. Just make sure you can fit them both on the number line. Put 0 here, -1, -2, -3. 1, 2, 3, 4, 5. I can fit one more. All right, and you'll just take them one at a time. Open circle at -2, shading this way. Closed circle at 5, shading this way. So you can see there's not a number that will satisfy both. You have an empty space in between. Now for both of these, you can solve these things. The or ones are pretty simple, so I'm going to start with one of those. Let's say that I've got 3 times t is plus 2 is less than or equal to -7, or -4t is less than -4. Something like that. So you've basically just have double the work here. You've got two inequalities. You're going to have to solve both of them. Not a big deal. Just take some time. So I'm going to minus 2 on each side here. That goes away. I've got 3t is less than or equal to -9. Divide by 3. I am not dividing by negative. So that's just going to be t is less than or equal to -3. So there's my first one. Or I'll solve my other one. This one I just have to divide by -4. But when you divide by negative, you flip the symbol around. So that's t is greater than 1. And just kind of make sure that there's not going to be anything that matches. Nope, there's not going to be a number that will fit both of them. So when you graph, simply draw your number line. Make sure you can fit both numbers on your number line. I'm going to put 0 up here. 1, 2, -1, -2, here's -3. And do your shading. I'm going to have a closed circle on -3 and shading this way. I'm going to have an open circle on the 1 and shading this way. Make sure there's no overlap. Make sure you're doing both arrows and you should be good. Now with the and ones, it's a little trickier because you're basically looking at an inequality that has 3 sections. So when you solve, you're just going to solve all 3 sections. Let's say I've got -3 is less than or equal to m minus 4. And we'll make that all less than -1. Looks kind of scary, right? But what I'm actually going to do is I'm going to draw 2 walls. And I'm just going to think of this as a 3-sided inequality. We're used to 2-sided. We're going to go with 3-sided. This middle part is what I want to work on. I want to get the m all by itself. So to get rid of this +4, I'm going to +4 here. And I'm going to +4 here. And guess what? I'm going to +4 here. See, we just +4 to everything, all sides. We're used to just having 2 sides. This one has 3. No big deal. You just got to make sure to do the same thing to all 3 sides. Once you do that, you just simply calculate each one. -3 + 4 is 1. Drop down the same symbol. The m is left by himself in here. Drop down the symbol. -1 is +4 is 3. So here is my answer. And now let's graph it. So here's 0. Here's 1, 2, 3, 4. I probably should have numbered my number line differently because I'm going to have a big part that I don't even use, and that's okay. So I'm going to have a closed circle on the 1 because of that. I'm going to have an open circle on the 3, and I'm going to shade in between. All right. I hope this has been helpful.